Now, let's talk about the RAID. What is RAID? So RAID is a redundant array of independent disks. So imagine that you have the multiple hard disks. So imagine in your system, for example, you have that. This is not for the laptops or the desktops. This is for the servers. So imagine you have a server and you have, for example, the 10 hard disks. How can you benefit from these 10 hard disks? Right? So there you have the multiple options now. For example, let's say if you have the 10 1 terabyte hard disks, what you can do is you can get the 10 terabyte of the space, right? So this is very good option. So you have 10 hard drives, each is 1 terabyte. So now you have the 10 terabyte space for your server. This is one option. Another option is, let's say we use the sum of them for the backup. So what we do is we have the 5 terabyte for the data and then the 5 terabyte for the backup. This is another good option as well, right? Because in case if something happens to your original data because of some damage, you always have a backup. So this is now another way of utilizing your 10 terabytes of the space or the 10 different hard disks. Okay? So the RAID is such concept of the different concepts of how we can utilize, how we can benefit from the different number of hard disks. And these are the RAID levels. So they call the levels, but in reality these are not the levels. They are not connected to each other. Okay, so just the types. Imagine them as the types. We call them RAID levels, but these are just the different types of or different methods of organizing the hard disks. So for example, the number one is a RAID. Let's look at the. Let's look at this one, the RAID level 0. In this case, there is no redundancy. Okay, and in this case, you have the high. In this case, you have the high capacity. So this is the first option when you have the 10 disks and then you have the 10 terabyte of the space. So number two is the mirrored. So this is what we mentioned right now. So if you have the 5 terabytes for the data, then you have the 5 terabytes for the backup. So actually we're going to discuss this in a minute, but this is just a comparison table for the different levels. Okay, so let's look at the RAID number 0. So RAID 0, in this case, what you can do is you use all of your hard disks to store the data. That's it. So this one, for example, you have the disk number 1, disk number 2, disk number 3, disk number 4, and you have the 4 disks. If each one is 1 terabyte, then you have the 4 terabyte of the space. Good. So you have the 4 terabyte of the space. But when you store the data, what happens is that the data is divided into the strips. So your original data, for example, you have the movie. Let's say you want to store the big movie. Let's say that this is 5 GB movie in a hard drive. What happens is that your movie will be divided into the smaller strips, and each strip will be stored inside the different hard disks. So this is important. So if, for example, again you have a movie, this is one file, and then this file is divided into the 4 strips. Okay, the first strip will go to the first hard disk. Second strip will go to the second hard disk. The third strip will go to the third hard disk, and the fourth strip will go to the fourth hard disk. Why? Because in case if, for example, the hard disk 1 is damaged, you still have the other part of your data. Okay, even if the one hard drive is failed, you still have the 3/4 of your data. Okay, so that's why it's important not to put all the eggs in one basket, right? So you have the multiple baskets, put them in multiple, put the eggs in multiple baskets. So same is happening here. So you have the 4 terabyte of space, and then you have some data divided into the different hard disks. Again, in this case, there is no redundancy. So meaning that you are utilizing all the space. So you have the full capacity. If you have the 4 disks, you have the 4 terabyte. RAID number 1 is mirrored. So in this case, you have, for example, 4 terabyte for the data, another 4 terabyte for the backup. So this is just the exact mirror copy. So this part and this part, it's a mirror copy. That's why it's called a mirror, right? So again, you have the 4 terabyte, another 4 terabyte for the backup. So if you have the 8 terabyte of the disks, then your actual capacity will be at the 4 terabyte. Okay. RAID number 2 is, in this case, you have the redundancy through the Hamming code. So we talked about the Hamming code at the last chapter. So the Hamming code is the, if you remember, we have the error correction codes. So you can generate the error correction codes. So in this case, what happens is for each 4 bit of the data, you generate the 3 bits of the error correction codes. So this 4 bits is your data, and these 3 bits are used to recover the damaged data. So in this case, you have for example, the 4 disks will be used to store the data, and 3 disks will be used to store the error correction data. Okay. So in this case, you need how many? If you look at the RAID number 1, you need the n plus m number of hard disks, and m is actually depends on the number of n. So we already talked about how you can choose, for example, for the 8 bits plus how many m bits you need. So this one you can refer to the table from the previous chapter, right? So for example, for the 128 bits, you need some extra m bits of the data for the backup. So this is how it's organized. In this case, you have the RAID number 3. With RAID number 3, what you can do is you can have always the m plus 1 disks. Okay, so in this case, again, let's look. You have the n plus 1 number of disks. Okay, so in this case, the n disks here will be used for the storing the data, and 1 disk will be used to store to put the backup. Okay, same with RAID number 4, but the difference between the RAID number 3 and RAID number 4 is the RAID number 3 is at the bit level. So the data is stored in a bit level. Okay, so bit number 0, bit number 1, bit number 2, bit number 3. So each bit is stored inside a different hard disks. In this case, it's in a block level. So block number 0, block number 1, etc. So one block contains the same number of bits. So this is the only difference. Difference between the RAID number 4 and RAID number 5 is that this disk is actually distributed inside the other disks. That's it. So with, for example, RAID number 3 and RAID number 4, you have the dedicated hard disk, separate hard disk to store these parity bits. So this is called the parity bit, right? So this is called the parity bits to use to recover the data. In case of the RAID number 5, these parity bits, instead of being stored inside the one separate hard disk, they're actually distributed across the multiple hard disks. So this is the difference between the RAID number 5 and RAID number 4. With RAID number 6, what you have the dual redundancy. Now, instead of the single parity bit or single parity block, you have the 2 parity blocks. So you can see the P and Q, P and Q, P and Q, P and Q here. So you have instead of single, this means that you can fix more errors and you can detect even more errors. Okay, so this is the only difference. So as you can see, these are the number of ways how you can organize the different these hard disks and how you can benefit from them. But usually what happens is that from your system perspective, from the operating system, for example, you have some Linux or Windows operating system. From the Windows operating system perspective, you will not see the 8 or 5 or 10 hard disks. You will see the one logical hard disk. Okay, so from the operating system perspective, if you look here, here you can see the one logic disk. This is one hard disk. This is one logical disk, virtual disk, right? Of course, this logical disk is now connected to the multiple physical hard disks. Okay, but when your operating system, so this is, let's say, your OS, could be the Windows, could be the Linux, refers to the hard drive, it will refer as one single hard disk.